Optical illusions are a very interesting topic, and it starts with the question, do we see things for what they are, or do we see things for what we think they are? It starts with the vision system. The optic nerve, the retina, the cornea, lateral geniculate nuclei, and the visual cortex all play a large role in how it works and how we see what we see. Light reflects off images and enters the eye through the cornea. It is then focused onto the retina through the lens, through a process called accommodation. Specialized cells in the retina convert the light rays into electrical signals. Those signals are sent through the neural pathways to the brain, and these neural pathways are by the optic nerve, through the lateral geniculate nuclei, and lastly, the visual cortex of the brain, and this is where we see the images. Now that we have the fundamentals of how we actually see down, we're going to talk more about the three main types of optical illusions. The first type of optical illusions we're going to talk about today are called literal optical illusions. And these type of optical illusions are created from little more detailed pictures that make up the whole. So as you can see in our first example, we see a portrait of a man and he's looking at a straight on. But if you look more closely, this man is made up of different fruits and vegetables. So when we look at it at first, our brains look at the bigger picture as a whole and we see a man. And we don't look at first at all of the mini details that make up this picture. And in the next picture, painted by the famous surrealist Salvador Dali, we look at an elderly couple, and since this is the main picture, this is what we're drawn to first. But if you look at it a little more closely, we see two people, one's playing a guitar and one's listening, and the smaller people make up the bigger people. But as I said before, our brains are going to try to distinguish the bigger, more generalized picture at first. So from this we learn that literal illusions are when images that we see differ from the objects that make them up. The second type of optical illusions we're going to be talking about are called physiological optical illusions. And these type of illusions occur when we experience really bright lights or colors or movement or different things like that. So when this happens, only one or two neural pathways are being stimulated. And when these pathways are being repeatedly stimulated by the same color or movement or pattern, then the other neural pathways start to get imbalanced, and this slightly alters our perception. In this example, we see the Hermann grid illusion. And this illusion shows a white grid with black squares in between. And after a few seconds, you'll begin to notice dark blobs in the intersections of this grid. And this is because the bright white and the really dark black contrast, and since you're looking at it for so long, those neural pathways are being stimulated, which throws off your other neural pathways and imbalances it so that you're seeing things that aren't really there. So from this example, we see that when you're using those neural pathways that are really focused on the white and the black and getting the pattern down, you're actually throwing off your other neural pathways and you're seeing things and altering your perception, and you're seeing things that aren't really there. The final type of optical illusion we're going to be talking about are called cognitive illusions, and these are the most common and probably the ones that you're all most familiar with. And these type of illusions occur because of our preconceived knowledge and ideas of what things should look like. And these type of illusions misdirect that and trick our minds into thinking we see something that we don't. So another really important part of cognitive illusions and what makes them happen are what are called blind spots. And blind spots occur where the optic nerve leaves the eye, and at this point there are no receptor cells, which is why they're blind spots. So the way our brain deals with blind spots is by filling it in with similar colors and surrounding colors of the object that we're trying to process. In this image, we see two boxes. On the top, there's a dark gray box and a light gray box on the bottom. And at first, we can all agree that these two boxes are different shades of gray, but they're actually the same exact shade. So now if we look at the same picture with a pencil covering the line that separates the two boxes, now we can see that they're the same shade of gray. And this happens because our brain has a preconceived idea that the bottom should be lighter because of its shadow and because its background is darker. And we also think that the top should be darker because its background is lighter. So because our brain is telling us this, it's really hard to look past the optical illusion of it and see that they are actually the same shade of gray. Now that we know the three main types of optical illusions, it's also important to say that optical illusions aren't just in our own heads. They're also influenced by the world around us. They're influenced by the color of the object, the color of the light hitting the object, and lastly, the colors in between you and the object. So next time you look at something, think about it. Do you see what's actually there, or do you see what you think you should be seeing?